Hello all and welcome back. So in this video, let's continue our discussion on recursion and string and solve another question. The question is permutations of a string and has been asked in many companies including Google, Disney, Ola to name a few. This question will help us to actually understand few concepts and the same will actually be useful in solving other questions in recursion as well as in DP. So let's get started. Now before actually moving forward, first let me define what permutations of a string or of any sequence is. So let's say if you are given a string ABC, then permutations are actually all the ways you can arrange this string, right? So for example, we can arrange this string as ABC only, that's first permutation. Then we can do BAC, right? And then we can do CAB. Okay, these are the permutations because it is containing the same characters as in my original string. Are there any more? I believe yes. So it can have ACB, then we can have BCA and finally CBA. Okay, and I think these are the number of permutations which are possible for a string. Now there is actually a formula for this as well. So n factorial for a string of size n. This is how many permutations a string is. How we can get to that? We have three places. Okay, so we have to take each and every character, right? Here we have three choices. Here we have two, the leftover, and here we have one. Something which we have done, like this is what the overall idea about permutation used to be. So just a quick refresher. Now to understand this in parallel with the subsequence problem which we did, this time we have to make sure that we are taking each and every character and the sequence doesn't matter, right? This is how I can actually define this problem in a very easy way. So what I'm saying is that ABC is there and I'm saying that, hey, you can take each and every character and I don't care about the sequence. If you are taking ABC, for me that is different than CBA, right? So that's the whole understanding, everyone. So let us now define the code skeleton as well and then we will do it. This time we are going to do the print subsequent thing first. Print permutation thing first, right? And then we are going to move to return one. Great. So yeah, once this is completed, it should give us the answer. Now in the last class, in the last video, I made sure that I explained you very nicely that how exactly we reach or we try to attempt the print kind of a question in recursion. Please make sure that you see that because the same is going to be a lot helpful going forward in concepts like backtracking as well. Now let me actually draw this question. Okay, so let's say if we have ABC and we have a empty string initially, right? So this was taken so far, which we understood in the last video. Now the understanding is the same. You have three dishes in front of you and you have an empty plate. And this time you can actually take all the dishes. You have to rather take all the dishes and the sequence actually matters. So let us see this, everyone. Now the very first time what you can do is you can of course take a single dish. Okay. So your plate now has A. There is no choice of leaving this. You have to take it. But now the question arises, okay, how are different ways we can take it? Okay. So what all I'm saying is, if let's say there are A, B and C and you have a plate here, you have to take this. Okay. Then you have to take this, but this time it can be taken in both the ways. If A is already being taken, if A is already being taken here, then you can take it here or here. And this sequence is different, right? This sequence is different. With that in mind, I hope you understand that what exactly is going to happen. Once we have taken this A, and now we have to make this choice for B, right? I have two choices for B. What are these two choices? Either I can add it before A or I can add it after A. And these are both different choices, right? Because they will result in different permutations for me. With that in mind, I can say that, okay, if I put it forward, then it's going to be BA. And if I put it afterwards, it's going to be AB. Okay. Now, in a very similar manner, we have to now take the choice for C. If the question would have been just AB, then you will see that, okay, we have actually gotten our answer, right? So kind of it can be broken down into recursion in a way similarly that if we are, let's say solving for AB, if we are just solving for AB, then this C would not have been there. We would have an empty string here and we have gotten our answer. But let me just draw it again for C as well, everyone. So for C again, we have three choices this time, 1, 2 and 3. Here also 1, 2 and 3. And each of these choices is going to result in a different permutation, and that's the major thing. So pay attention. It's an empty string now because we have exhausted or seen all the things. Now it's CBA. Similarly, this is going to be BCA, and this is going to be BAC, right everyone? In a very similar manner, this is going to be an empty string here, and CAB, an empty string CACB. So I'm just like doing it. Here you will see it's at the first point, here it's at the second point, and in the end it will be at the last point. C here is at the first position, at the middle position, and at the last position, right? And now everyone, A, B, C. Okay. So I hope with that you understood the overall idea behind this question. Now one thing which you will actually see here, which we have not done in any prior question, here the number of calls of recursion are actually going to be variable. So till now, whenever we are trying to make a recursion tree, okay, this is very analogous to a recursion tree, always we were making same calls, right? And let me write this down because this is a very important stuff. Variable recursion call are here, right? And you will see that you have actually got your answer. So this is CBA is 1, BCA is 1, BSC, CAB, ACB, and ABC. Here where we have to make 1 calls, here 2 calls are there, and here 3 calls are there. Okay, so this is the first time we are seeing some question, and this is the major idea behind actually making you do this question, that we are now actually dealing with multiple recursions call. It is not fixed. As of now, when we are making a tree, right, whenever we are making a tree, it used to be divided in a similar fashion. But here, depending on what we have till now, or depending on the input or the output, we are making variable recursion calls. I'm making 3 calls here. If I would have had let's say another dish or D here, I would have made 4 calls in the next part, right? So the calls are actually increasing. If that's happening, then I hope you understand that we have to actually use loop, right? So this basically means that loop will be used, right everyone? So we will have to use a loop. So now let us go and actually try to write the code for this. I hope the understanding is clear. Again, we have to take one empty because this is going to be my taken so far, because else I cannot tell my recursion that what I have taken, what I have not taken. Okay. Now the understanding is that if length of my S1 initially is 0, I should just print whatever I have taken, and return. Again, if the empty is there, if the string is empty, then just have a single permutation which is empty. Okay. Now pay attention everyone here. Whenever this was empty, that is where we used to get the answer. So again, the understanding is same. Once this becomes empty, I'm going to get my answer. Okay. Cool. So next is first char, or let's say R char, where we are going to work. It's equal to S1 of 0. Okay. Then small input we are dividing is going to be S1 of 1 is to this, right? So now pay attention, small input is equal to this. My bad, not in a list. Yeah. Now what's going to happen everyone? Now what's going to happen is that pay attention once. So it will not have a small input here, like we were not having or dividing it like this. We were always sending this C, so that should be fine. So let me have this, should be fine. Okay. Now pay attention everyone, what's going to exactly happen. I am saying that we have to make these calls which are variable. But how are these calls getting made? How exactly are these calls getting made? Okay, let me take an example of this C, B, A and A. Okay, and let me try to explain you. So all I'm saying is, let me take this particular example C, where I have C left and I have B and A with me. Okay. Now if you will see, the first call which I am making is actually here. This is where my first call is. This is where my second call is going to be. And this is where my third call is going to be, right? This exactly is what's happening, right? I'm making a recursion call here, which is on the first part, which is on the first, this, then second call here, which is here, and third call here. In a way, I have to make sure this BA was taken so far. So I will have to make sure to somehow calculate how many locations I have in my taken so far. If I'm able to calculate it and add my this particular character to those locations, I will be done. Now, how can I do that? I think the slicing function can help us a lot in this. Okay, so pay attention everyone, what's going to happen. I'm going to take the length of this. I'm going to take length of this, which is going to be 2. Okay. And I'm going to run a loop. Starting from 0, which goes all the way to 2. So it's going to run for 2 as well. Okay. And I'm going to now divide this particular string. So let's say my output, remove it, yeah. 1 second, yeah. So my output as of now is equals to B and A. So if I do output 0 till 0 plus output 0 till end, this is going to actually give me this particular location here, right? If I add my character in between, it's going to get added in the starting, because this is going to be an empty list and this is having my everything, right? So this is for when I is equals to 0. Similarly, when my I is equals to 1, output 0 is to 1 plus, and I can add it in the middle, output 1 towards the end. So here I am actually catching this particular position. So all I'm doing is I'm trying to actually get all these positions, and I am just doing it with the help of a loop where I'm slicing my string. So the very first time I try to find this particular position, for this I need to have nothing in the starting. So this is what it is, and the whole string here, and the whole string is here. So effectively I can say this can be I, and I will get all my combinations, right? So this, if this is I and this is I equals to 1, if we will run it for 2 as well, let me run it quickly. If my output, so output is basically taken so far, nothing else. It's 0 to 2, it's going to be the whole string plus output 2 till end. Now if you have an idea about slicing, if this is BC, it is going to be 0 and 1, and at 2 it's going to give you an empty string, but this is going to give you the full string. Now let me see and let me showcase you this as well, because this is a little bit tricky thing and major thing to understand. So pay attention everyone once. Return as it is, yeah. So all I'm saying is for I in range, I'm going to run it for 0 till length of my taken so far, how many things I have, plus 1. And now I will just call this function. I will just print this permutations. Okay. First I have to make sure that I'm calling this on the small input. So I have to just make sure that at every step I'm making my input small. Once I have seen a dish, I have to make sure that I move to the next one. So this is what I'm going to pass, small input. But here, these particular things is where the main things are happening, right? This is where the main logic is happening. Now I have to make sure that I add, so for this particular thing, I have to make sure that I add B first here and then make these recursive calls, right? So for this particular use case only, I am saying do it like this. Taken so far, 0 is to I plus whatever R character is plus taken so far, I is till the end. And now it's going to run perfectly fine. And I can show you this as well. So pay attention. Let me just print this for the timing. Let me just remove it. And let me pass AB for the time. Okay, AB I'm passing, or let me pass BC. Okay, so this I'm taking this one only. So I've taken so far is BA. My taken so far is BA. And this is C. Okay, so if I will run it right now, I'm not making any recursion call. It will just run and print this particular thing and show you what exactly we are getting. So pay attention. I'm getting CBA, BCA and BAC. CBA, BCA and BAC. Now the reason I'm going a little depth and explaining you all this thing is because we will be using this in further questions and the assignment which I'm giving you. And these are the major places where I've seen students facing the problem. And you can imagine, right, if companies like Google and Disney are asking these questions, there is something, right, which they expect that the person will be a lot having a mastery on. And these are the small things. So along with recursion, you should have a good idea about string basics, how we use slicing, and thus it becomes a question which is a good overall question to test out the candidates. So great everyone. With that, I hope this is clear. So now let me remove this. And I think our code is done. We can just call it. Let me run it. We are able to get all the permutations, right? I hope you understand exactly using the tree, and you will notice one more thing, right? Like always, CBA, BCA, BAC, CBA, BCA, BAC, CAB, ACB, and ABC. CAB, ACB, and ABC. Okay. So this thing always should match if you have made your tree properly. If it is not matching, please don't leave the question. Try to do it again. Try to see where you have made the mistake. Because ideally, the way you are making your recursion tree, that should translate into the way you are making this particular tree, that should translate into your code. Okay. So this thing is very, very important to understand, everyone. We are not here to just solve the question. We have to make sure that we understand everything. And then when these companies ask us the same question, we are able to crack these companies. Okay. Cool, everyone. So now let's meet in the next video where we are going to do the return as a list of the same thing. Okay. Cool. Thank you very much, everyone. Please make sure that you revise that, and let's meet in the next video.